Hello everyone. Today I will be talking about OOD, otherwise known as Object-Oriented Design. So, Object-Oriented Design revolves around classes that define attributes and behaviors of objects. Objects are instances of these classes and interact through defined interfaces, emphasizing principles of encapsulation, abstraction, inheritance, and polymorphism. OOD in Java aims for organized, modular, and easily maintainable code for modeling real-world entities as objects and their interactions. So here's my scenario that I just created. It is based on playlists because I just really love this idea. So the scenario states, within our music platform, users sign up and start creating playlists effortlessly, arranging tracks and slotting songs into different playlists while enjoying uninterrupted playback. Discovering a full album by a favorite artist allows for seamless organization of individual songs into various playlists. The platform's recommendation system pleasantly surprises users with new artists perfectly aligned with their tastes. Collaborating on playlists with friends becomes easy as they add, remove, and reorder tracks effortlessly. Exploring subscription tiers. Users can upgrade to access exclusive live recordings, enhancing their music experience beyond the usual library. So obviously, I mainly picked these 5 classes, but as you go deeper and deeper, you can make subscription as a class and even more if it comes to paying for the subscription. Money could be a class, or so on. You can make tens and you can add on to classes as you make it more detailed. So here I just identified the classes and interfaces. For example, I also added the methods that would be required for each class. So for example, here I have the user class. I stated the role. It represents a user registered on the music streaming platform, and then I specify the attributes such as username, playlist, and then I just mentioned the methods that will be used for creating this user class. So I just stated that for all of my 5 classes. And also the interfaces. For example, here, the playable interface, I stated the role, which says that specifies items that can be played, such as songs and albums, and the methods such as play method, the method to play the item. And I just restated the classes and interfaces here, and then I moved on to the CRC cards. So CRC cards are basically similar to what I did here, but I also added, basically it also adds the collaboration part, which is when it mentions what class you will be collaborating for that given class. So let's take an example here, the user class. So we just list the responsibilities of that class, such as the user creates the playlist. And we go to the collaboration. So what class are we collaborating with for this? We are collaborating with the playlist class, and the user creates the playlist. And so on. The next responsibility is to add songs to the playlist. So obviously we will be collaborating with the playlist class and the song class, and yeah, it just goes on like that. I did the CRC, like the responsibility and the collaboration for each class, and I just stated them into 2 columns. Next, we will be talking about object aggregation. Okay, let's start from the definition. So object aggregation refers to a relationship where one object contains another object as a part of its own structure. It represents a has-a relationship between classes, where one class is composed of or owns another class as a part of its as a part or component. So the explanation just adds on to the definition. You can always pause the video and look at it. Let's look at an example for aggregation. For example, there is user and playlist. Within the music streaming service, a user manages multiple playlists. A user has a personal collection of playlists created based on the preference, mood, or activities. So here we also have an illustration, like imagine a user's account dashboard where they can view, create, edit, or delete playlists, showcasing one-to-many relationship between the user and playlist. So here's another example. You can always pause and look at it. And let's talk about the contribution to problem solving. So object aggregation allows for modular design by composing complex objects from simpler ones. This contributes to code reusability and creating smaller reusable components that can be used in various contexts. It also helps represent complex relationship between objects, allowing them to be structured in a way that mirrors real-world scenarios. Now let's move on to inheritance. So inheritance is a mechanism in object-oriented programming that allows a new class to inherit properties, attributes, and behavior from the existing class. It enables a hierarchy where one class inherits the characteristics of another. Let's look at an example. Songs and albums. So songs and albums might share properties or behaviors through a generalized class. For example, song and albums might have a common attribute like title, artist, or duration. And here's an illustration. Obviously, you guys know what it looks like since you've seen songs and albums and, for example, Spotify. So let's look at the contribution to problem solving. It helps us reuse the code as one class extends another class, so you don't have to keep writing the code. It is time consuming. Now the next contribution is hierarchical organization. It aids to structuring classes in a hierarchical manner, creating a clear and local organization of related classes. Next, let's move on to polymorphism. So polymorphism refers to the ability of different classes to be treated as instances of the same class through a common interface. It allows objects of different classes to be used interchangeably based on their common behavior. One such example can be playable entity. So here, different entities such as song, album, and playlist implement a common playable interface. each entity provides a different method to be played, but implements it differently based on its nature. So an illustration would be songs, albums, and playlists can all be played, but the behavior of playing a song differs from playing an entire album or a playlist of songs. And let's talk about the contribution to problem solving. Polymorphism provides flexibility by allowing different objects to be treated uniformly through a common interface. It enables writing code that can work with objects or various types without needing to know their specific implementation, contributing to adaptability and ease of extending functionality. It also contributes to simplifying the code and easy maintenance. So hence it is required to design a object-oriented design before starting your object-oriented programming. Thank you.